Good day, Sir Ray. Good morning, my dear classmates. So today I will be discussing my report or my requirements, which is about the analysis and design of a medium-rise building. So punta muna tayo sa National Building Code. Sabi rito, yung medium-rise building natin, it's about from 6 to 15 stories, which is 19 meters to 46 meters, inclusive an average of 1 meter per version for parapet wall or roof apex. Excludes maximum allowance for 6 meters tall antenna steel tower on top of the structure, which is it's only were allowed by the Civil Aviation Authority of the Philippines or the CEP. So kung titingnan natin, dito lang tayo magbabase sa stories, so which is equivalent to sa 16-15 stories. Then check natin yung elevation. Kapag magre-range ng 19 meters to 46 meters, your structure can be considered as medium-rise building. Okay, let's continue. Okay, so bali, yung ginawa kong structure is the design of the 7 stories apartment building with roof deck, situated at the Barangay Santa Prudenciana, Mapanas, Northern Samar. So let's check the parameters, the plans, and the elevations of this structure. As you can see in the NGL plan or the ground floor, by the way, yung level ng NGL and ground floor, so same lang as per my design. So kung makikita ninyo, that is 1, 2, 3, this is 12 plus 2.5, that is 14.5 meters by 1, 2, that is 12.5 by 14.5, 7 stories residential apartment building. Okay, then may shear wall tayo sa gitna. Then let's come now to the second floor to 7th floor, which is the typical floor natin. So as you can see, may dalawa tayong staircase, which is dalawang stair natin, the left and right, which is along the grade line 3 to 4. Okay, then yung roof deck natin, bali close lang siya, inaccessible siya, so hindi kino-consider ko siya as roof deck lang, as is roof lang. Then punta tayo dito sa elevations. Balik muna tayo sa dimension. Okay, as you can see, yung pinaka initial condition ko, initial dimension ng beams is 300 by 400. Same with the upper floors, upper beams. Then in the elevations at grid line A, as you can see in the plan, this is grade line A. So kapag tingnan natin yan, so this is the elevations. Then the initial condition natin, initial assumption of the size of the column, which is equals to 400 by 400. Then yung assumption natin from the foundation to the natural grade line is 2 meters. Then from natural grade line up to roof deck level, so bali same elevation sila per stories, which is equals to 3 meters. Okay, ito naman sa grade line 1. So as you can see in the 3D model, so yon, ito yung structural 3D model natin. yung perspective. Then yung detail din natin sa sa shear wall, which is ito. So bali, from the face of this wall to the other end, so mayroon siyang 2.3 meters, same with the other axis. Tapos may assumption tayo na 200 mm na thickness ng shear wall. Tapos yung opening natin sa elevator is 1.2 meters. Tapos may height tayo na 2.1. Okay? Then while in the stair detail natin, so ang ko dito, i-model ko na lang yan sa structure. So bali may 1.5 tayo na width ng stair, same with the first and second flight. Then dito sa landing may 1.2 meters tayo, which is the width. Then may length tayo na 3 meters. Then 1.5 meters height at every flight. So ito yung sinabi. So yung elevation natin or the height is 1.5, tapos 1.5 dun sa taas. So mapapansin niyo that is 3 meters. Then of course the assumption is use that 125 mm thickness na stair, yung slab ng stair. Okay, so balik tayo. Ito pala, for the assumption of the slabs, the floor thickness, so use 125 mm slab thickness. Then punta tayo sa home. So the design specification or the reference for ito yung NSCP natin 2015, the ACI 3810-14 for concrete, then the UBC 1997 for the earthquake, and ESC 7-10 for the wind. Okay, for the materials, we use the concrete and the rebars. For the concrete, we use the F'(C) or the compressive strength of 20.7 megapascal or 3000 psi. While in the rebars, may dalawang class tayo, which is the main bars or the Fy is equals to 415 megapascal or 60 ksi. Then yung FYS natin, or for the stirrups and for the ties, this is we can use 275 megapascal or 4000 ksi. So bali, yung main bars natin, that is grade 60, then grade 40 yung natin para sa stirrups and ties as per ESTM 615. Okay. Then sige, discuss muna natin yung loadings. Okay, for the loadings, so may dead load tayo. Then under sa dead load, may self weight tayo, which is the weight of the members, structural members. Then yung unit weight natin ng concrete, yung gagamitin natin is 23.5631 kilonewton per cubic meter. Then may superimposed dead load tayo, or the SDL, as per section 204 NSCP 2015. So bali gagamitin nating exterior walls dito is the 100 mm CHB wall. So may 2.98 kPa tayo, which is including yan yung dalawang face ng plastering. As you can see in the section 204 dito sa para sa 100 mm, so bali ito yung gagamit natin. Yung assumption natin rito is the full grout na wall para sa weight natin. Yung para sa 100 mm, so bali yung weight natin or the load is 2.5 kPa. So mayroong dalawa pa tayong 0.24 kPa para sa dalawang faces. Kaya abot yan and to 2.98 kPa. So balik tayo, check natin nun. Ito, as you can see in the formula, that is 2.5 plus 0.24 plus times 2. So 2.98 kPa. Yung exterior walls natin, i-apply natin yan mamaya. Okay, for the floor loads naman, for the upper floor natin, may floor finish tayo, partition load, ceiling, insulations, which is include yung mga sa mechanical natin, insulation. Okay, then waterproofing, then EME plumbing. So as you can see in the NSCP, or kapag wala sa NSCP, you can use the internet or the search bar in the Google para makuha ninyo yung specific na materials. Ang kailangan kasi natin yung unit weight, yung unit weight ng per materials. Okay, so bali yung sinearch ko dun sa Google, ito yung waterproofing kasi wala dun yung waterproofing. Okay, so pag i-plus natin yan, naabot yan ng 2.69 kPa for the typical floors. So second floor up to the 7th floors. Okay, yung 7th floors, okay na yan, 7 floors wala kay. Then, while in the NGL is 2.1. Bakit 2.1 kPa lang? As you can see in the formula, ito lang yung floor finish plus the partition load. Kasi wala nang ceiling, walang insulation, walang waterproofing, then walang plumbing, yung assumption ko rito. Then while in the roof deck, may 0.59 tayo. Bakit 0.59 kPa? As you can see, yung magiging load lang natin doon is the ceiling insulation, waterproofing, then the EME plumbing accessories. Okay, so wala na tayong floor finish doon. In-assume ko na walang floor finish. Ito na yung waterproofing na yan. Then wala, of course, walang partition load. Let's continue. Let's come now in the live loads. For the ground floor, assume ko is 2.4 kPa as per section 205 NSCP 2015. Then the above ground floor is 1.9 kPa. So as you can see, kapag residential, as per the NSCP, kasi residential naman yung i-design natin, so yung basic floor load is 1.9 kPa. Ito. Okay. Let's continue. So para sa roof live loads naman, so pupunta tayo ng section 205.4 ng NSCP 2015. So yung roof load natin, yung assumption case, papasok tayo sa 1.32 kPa. Bakit again 1.32 kPa? That is 0.6 plus 1.2 times 0.6. Kasi yung 0.6 natin, as you can see, that is ang load ng flat roof. Ito yon, yung 0.6 natin. So over 60 yung tributary area kasi malaki yan. So 0.6. Tapos kung mapapansin niyo, may 3 yan, may 3 na designation yan. So babasahin natin yung 3. A flat roof is any roof with a slope less than 1 unit vertical and 48 unit horizontal or the 2% slope. The live load for flat roofs is in addition to the panding load required by section 26.7. So bali, additional panding pa tayo doon. 26.7, kapag balikan natin 26.7, that is the water accumulation. Sabi naman doon sa section 26.7, all roofs shall be designed with sufficient slope or camber to ensure adequate drainage after the long-term deflection from the dead load or shall be designed to persist panding load. P combined in accordance with the section 203.3 or 203.4. Panding load shall include water accumulation from any source due to deflection. So, yung section na to, this is the load combination. Kapag i-check natin yung other loads rito, sabi rito, where P is to be considered in design, the application load shall be added to section 203.3.1 factored as 1.2P. Kasi, kaya, yung load ko para sa panding or para sa rough live load is 1.2 times P. So, may additional siya na 1.2 para sa panding. So, balik tayo. Kaya, kung mapapansin nyo, yung rough load natin na 0.6 plus the panding, the 120% of the rough load. Okay, let's continue. So for the seismic load naman, as per NSCP or by the UBC 1997, we can use the X and Y direction. Then we can consider this positive and negative eccentricity. Then we can use the eccentricity ratio of 5% or the 0.05 and decimal. Then okay, so discuss muna natin to. Okay, so seismic, ito yun. Balikan natin mamaya after we model the structure. So then number 5, may wind load tayo as per NSCP 2015 or the ASCE 7-10. Then may mga coefficient tayo. Okay, so balik muna tayo dun sa model. Balik na tayo dun. Mag-model tayo na sa structure natin. Okay, so first mag-new model. Then use as build and setting, dapat naka-matrix tayo. Okay na din. Then okay ko muna to, mamaya ko na yan i-edit yung parameters natin. Okay, hintayin natin yan. Then close ko lang to. Gusto ko yung isa lang interface. Then dito ko na i-edit yung parameters natin. Then grid lines, modify, show grid lines. Then display grid data spacing. Yung bubbles natin i-reduce ko na lang yan ng mga 700. Okay, as spacing, okay, so as per sa parameters natin sa plans, that is yung along X direction natin, that's 3, 3, 2.5, 3, 3. Then tapos A, B, C, D yung F to F yung grid line natin. While in the Y direction, that is 1 to 4. Tapos lot siya 2.5 meters. Okay, so that is up to F. So mag-add ako dito ng up to F. Then change ko to ng 3 meters, 3 meters, then 2.5, 3 meters, and 3 meters. So kapag spacing, yung gagamitin niyo dapat naka-0 yung huli palagi. Then para sa Y direction naman, okay, so that is up to 6 grid line. So kailangan ko magdagdag ng dalawa. Spacing natin is lahat 2.5. Okay. Then as you can see, nagano siya, makikita natin yung update ng grid lines. Then kung okay na yan, so just click OK. Then punta na tayo doon sa elevation, the story data. So story data natin, as you can see in the elevation, Okay. So bali may 2 meters tayo from foundation to NGL. Tapos NGL to second floor 3 meters. Tapos yung typical natin up to 7 floors or the roof deck. So 3 meters na yung height natin. Okay. So bali 1, 2, 3, 4. Ilan yung kulang natin doon? Okay. So bali balik tayo. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 yung level na gagawin natin. This is 1, 2, 3, 4, 5. So kulang pa tayo ng 4. So click lang dito, right click, add story, keep existing story height. Then 4 yung kulang natin. 3 meters. Then number of added stories 4. Insert above story 4. Okay. Then inan lang yung replicate new story. Okay. So this is foundation. So yung designation natin, foundation. This is the NGL, 2F, 3F, 4F, 5F, 6F, 7F, and this is the RDL. Okay. Wait lang, hindi natin na-edit yung yung elevation, yung story height. So this is 2 meters. Then the rest is 3 meters. Okay na yan. So as you can see, yung elevation total distance natin, total elevation, that is 23 meters. Yung kapag i-compare natin dun sa qualification ng medium rise building as per National Building Code, so papasok tayo. Kasi that is between 19 meters to 46 meters. Okay. Then mag-set tayo ng master story. Yung master story, para once na every time mag-change tayo doon, yung kaparehas na story is automatically mag-change yung mga changes. Then yes natin to. Then the rest no. Bali yung master story natin is yung yung second floor. Tapos yung typical floor natin ito. Copy paste na lang natin to up to the 7th floor. Yan. Then okay. So ito na yung structure natin. So sa option, pwede natin yan i-change yung kulay. Dito lang yan sa option. Graphics color, display. Tapos yung for device type, yung white, tapos ito yung black. So pero for this presentation, I will use the white background. Okay. So yung assumption natin ng size ng structural frames, that is for the beams 300 by 400. Then para sa column, that is 400 by 400. So designation pala natin para mas madali as per survey. So dapat ganito yung pag-designate natin para mas madaling maintindihan. For example, sa 300 by 400 na beam, RB 300 by 400, that means that it means that the reinforced beam 300 by 400, which is the dimension. Then next is the FC, which is the compressive strength of the concrete, FC3, which is a 3 KSI. Then the FY 60, then FYS 40. So that is the strength of the rebar. Then same with the column, so i-change lang natin yung RC. Then sa slab naman, RS for represent for the reinforced slab. Okay, so balik tayo. So by the way, aside from assigning by the assuming a dimension of the structures, we can use the auto-select analysis of this software by using ETABS. Pero as per the initial condition natin, mag-assume tayo ng initial sizes. Okay. So first, we can define the material properties. Then add new materials, United States, then of course the concrete. Okay, then customary, in Northern Summer, the available concrete strength is only 3,000. Although some of the projects nakapag-provide naman sila ng mataas na strength, pero di ko lang alam kung available na rito yung concrete plant. Mahirap kasi mag-produce ng mataas na strength by manual mixing. So that's why 3,000 PSI yung available na strength ng Northern Summer. Then okay, then magpa-pop up yung properties niya, which is 23.5631 yung unit weight ng volume. Ito yung requirement natin. Then yung modulus of elasticity, automatically computed yan based sa F'(C) natin. Then okay, then add new materials ulit. Instead na concrete, rebar naman yung i-select natin. Then of course standard ESTM E615, then grid 60. Okay, as you can see in the left side, may E615 grid 60 na tayo. So bali yung grid 40 na lang yung i-select ko. Then okay, then ito yung unit weight per volume natin. Then okay na yan. So ito, may materials na tayo. Yung tatlo na itong tatlo yung kailangan natin. Then okay, after that we can now define a section. So define section properties, then frame section. Okay, as you can see, may mga default na section na tayo. So ako, pag nagde-design ako, dinidelete nyo na lang muna yan. So first, delete multiple properties, then drag all, then delete, then also delete the other section. Just click the OK. Okay, so may natira siya isang section, kasi hindi dapat mawalan ng section yung frame properties natin. Pero mamaya i-delete ko yan once na nakapag-formulate na tayo, nakapag-define ng section ng frame natin, structural frame. Then next, add new property, then of course the concrete, then okay. Wait to pop up the frame section property data. Okay, for our beam, so that is RB 300 by 400. Then the FC, which is the 3 KSI, the FY, that is 60 KSI, 60 PSI. For our rebars, that is 60 KSI. Tama na. Okay, 60 KSI. And for the FYS, for the ties, for the stirrups, is 40 KSI. Then of course, yung materials natin for concrete is 3,000 PSI. Then I can change the color of this beams, or we can set that as a default color, yellow. Okay, so hindi ka na yan change. Then yung size na natin, that is 300/400. Yung depth natin, yung 400 na yan, while in the width is 300 mm. As you can see, this section is for the column. So kailangan natin yan i-change. Okay. So let's come now in the property modifier. Just click. Okay, as per NSCP. Okay. And the table for 06.6.1.1a, yung column natin is 0.7, the gross moment of inertia. Then para sa slab is, for the beams is 0.35 times IG. Then the flat slab is 0.25 IG. As you can see, this is the table in the NSCP. So columns 0.7, beams 0.35, then the flat plates and flat slabs is 0.25. Okay. So that's why for the beams, kailangan natin i-reduce yung moment of inertia ng 0.35. Just click OK. Then click in the reinforcement properties. As you can see, kaya nakikita ninyo na for column section yan kasi naka-column yan yung default. So kailangan i-click natin is for the beam design. Then longitudinal grid 60, confinement bars, of course grid 40 yung gagamitin natin. For the cover to longitudinal rebar group centroid. Okay, yung sinasabi rito, this is not a concrete covering. So this is the assumption distance from the face of the beam to the centroid of the rebar, the main bars. So 60 okay na yan. Kasi bakit? So from the face of the beam, so yung concrete cover natin is 40 plus the assumption natin na 10 mm na stirrups. So 40 plus 10, 50 plus the half of the longitudinal bar or the main bars. Assumption natin 16 mm, so 8 mm yan. So 50 plus 8, that's 58 mm. So approximately 60. So okay na yan. Then okay na to. Then click OK. Then click OK. So may na-define na tayo para sa beam. So ito, i-delete ko na yan. Just delete this property. So para sa column naman, ay kakopy ko lang ito na designation. Copy. Then we can click the add copy property para mas madali na. Then i-paste ko lang yan. Then i-change ko to. Change ko yan. This is RC 400 by 400. Then same properties tayo. 3,000. Then ito, of course, dapat 4,000 yan. Then ang modifier, kailan i-change natin yan? Dahil column to, that is 0.7 as per the code. Then so in reinforcement property, instead of beam, we select the column design type. Then okay na to. Rectangular, then ties, then reinforcement to be designed. So i-design natin yan. Then kasi 300 yan, we can use 4x4 na bakal. Then 20 mm para sa main bars. Then for the confinement bars is 10 mm. Then okay, as you can see, this is the bars. You can reduce this. You can reduce the number of bars as per the data. Then click OK. So we have two properties. Then okay na yan. Ang dapat i-define pa natin is yung slab. So okay, define. Instead the section properties, section properties pa rin, pero instead the frame to section, slab section na tayo. Click slab section. Then yung may default na dalawang properties, you can delete this. So delete ka na lang yan. Then ito i-modify ka na lang yan. So this is RS 125. Then the FC, of course, the 3,000 or the 3 KSI. Then wala na tayong FY. Instead, FYS na lang, which is 40. Yung sa slab property or the material is 3,000. Okay. For the modeling type, we can use the shielding because i-act natin yan is part of the structural member ng structure. Pero if you use the membrane, this signifies that the slab is considered as only the carrier of the load. So hindi siya nagiging part ng structural members. So for this presentation, I can use the Shelton modeling type. Then of course the type, of course slab. Then the thickness, which is 125, the assumption natin. Then okay, yung 125 na yan, pasado na yan sa minimum thickness natin sa slab. Then of course sa deflection. Then okay. So pero ma-check pa rin natin yung deflection mamaya. Okay. So na-define na natin. Of course, ano pa ba yung define natin? Mamaya na yung shear wall. This time, kailangan muna natin i-model. So i-model muna natin yung beams, yung mga beams. So click plans. Then set natin yung NGL. Or pwede rin 2F na lang. 2F. Then kailangan natin ito dapat naka similar stories. Check natin similar stories. Dapat naka similar stories yan. Okay. Then click natin to, draw beams. Click. Then as you can see the properties, automatically may property na tayo, which is tama na yung gagamitin natin. RB dapat. Pero kung column, ito yung gagamitin natin. Then mag-draw na tayo. Draw tayo. So ang gagawin ko rito, dire-diretso ko muna yan. Then mamaya paputulin ko na din isa-isa. I mean lahatan na para mas madali. Okay, so ito replicate ko na lang yan. This is 3 meters. 3 meters. Ito highlight ko lang yan. Then Control R. So that is along x-axis. So 3 meters tayo, pero 1, 2, so dalawa lang. Then apply. Highlight ko to. Instead of 3 meters, 2.5 na lang, as you can see. Then isa lang. Ano yan? Then ito, i-replicate ko ulit by 3 meters. Tapos dalawang ulit. Yan. So para makita ninyo, pwede natin extrude. Just click this icon. So ito na yung beam natin. So ito i-replicate ko to, highlight. Then that is along y, positive y axis. So ito 0 yan. Ito, that is 2.5. Then ilang piraso? 1, 2, 3, 4, 5. That is 5 pieces. So as you can see, nakapag-model na tayo ng mga beams. Okay. Kapag i-click natin yan, continuous yan. Continuous. So ngayon ang gagawin natin, highlight natin to. Then ito yung edit frames, then divide frames. Tapos ito, pwede break at intersection with selected frame at joints. Pwede rin break at intersection with visible grid lines. So ito, pwede natin to by the visible grid lines. Then apply. Then kapag i-click natin yan, putol-putol na yan. Putol-putol na yan. Okay. So ito, i-reset ko muna. Show undeformed shape. Click yan. So by the way, before anything else, kailangan natin muna pala i-save. I-save natin to. So this is okay. Sabihin ko 4. Actually, minodel ko na yan. Mamaya i-check na lang natin. Sabihin ko 4. Okay, so okay na to, naka 4 na. Check natin yung 3D view. As you can see, nung nag-model tayo ng second floor, yung typical floor natin is nagkaroon na. So this time, balik tayo sa second floor. Highlight ko to. Or pwede rin, sige, model muna tayo. Mamaya na tayo mag-apply ng load. So highlight, Control R or the replicate, then story. I-replicate ko yan sa ground floor. So ito yung arrow na yan, papunta tayo sa NGL, then apply. So you can see mayroon na. Then balik tayo dun sa second floor, or pwede kahit hindi na. Then click na ko na lang yung PS or the previous selection. Then i-replicate ko yan sa RDL. Para makita natin, punta tayo sa RDL. Okay, so wala pang beams. So kapag i-replicate natin yan, meron na. So 3D view natin, meron na tayong mga beams. So ang kulang na lang dito is the slabs, the columns, the shear walls, and the stairs. Then click na lang natin elevation, so kahit anong grid line. Let's say grid line A.